All right, so hey guys, I'm pretty excited to share this with you guys. This is Packet Tracer, and this is kind of an emulator for how a network operates, right? So what I want to do today is I want to go over the OSI model. I want to look at some encapsulation. I want to look at a DNS query and an exchange of information, right? So we want to figure out with this is what is happening behind the scenes on the network whenever we're trying to get to a website, right? So what we can do here, we can open this PC on this network, open a browser, and then let's go over to our facebook.com, right? That's where we want to go. So facebook.com, and then go. All right, and then so first thing you'll notice is right, so the request is created. So this computer doesn't know where Facebook is, right? So we've got our fully qualified domain name, the facebook.com. And remember that computers don't read fully qualified domain names, right? They need a DNS server to tell them what is the IP address, right? They need it in binary. So the application, in this instance, your web browser, that is going to create a DNS query, and it's going to use UDP. Remember, DNS operates on UDP, and this is the source port from our computer. It's going to be outgoing, right? So the outgoing port 1044 and destination port 53, right? So 53 is DNS, and the IP header source IP, that's going to be, this is our, if you were to open this computer, this is going to be our source IP address, right? And the destination IP address is quad 8, right? So here is our DNS. If we open this up again real quick and go to config, we should see, right? So we've set the DNS on our computer as quad 8. Our default gateway is here, right? And then this is going to be our layer 2. Remember, our layer 2 is where we find MAC addresses, and then layer 1 is going to be the physical exchange of information itself, right? So, all right, so the DNS client, remember, client server, the DNS client sends a DNS query to the DNS server. This device encapsulates the PDU into a UDP segment, right? So layer 4 of the OSI model, UDP, it's a segment, packet data unit. And then the next, this is, remember, it's encapsulating as it goes down, right? As it goes down, it's encapsulating. As it's going up, it is de-encapsulating, okay? So it's encapsulating here. The source IP address is not specified. The device sets it to the port's IP address. The destination IP address is not in the same subnet and is not the broadcast address, right? So remember, whenever we're doing a DNS, at first it's going to check the cache on your machine, and then it's going to go check typically your default gateway is your secondary DNS server, and then failing that, then it goes to the DNS server that you have specified. Typically, either your ISP's DNS server, or you're going to set it manually yourself to like quad 8, right? So the default gateway is set. The device sets the next hop to default gateway. Sorry. So the next hop IP address is a unicast. Remember, unicast is one-to-one communication. All right. The ARP process looks it up in the ARP table, and the next hop IP address is in the ARP table, right? So ARP. Okay, so right here, I've restarted this so these switches are powered down so we can see them start to get powered up and see how they start to exchange information, right? So this right here is, we'll click on the data packets, right? So this is STP, right? Remember span tree protocol? It, as the switches are starting up, they're trying to define who is the root switch whenever it comes to the STP, right? So they're sending out multicast packets to all of the connected ports on the switch and trying to determine who is who, right? And this happens on layer 2. So we'll see this continue on for a good little bit. Try to speed this up. So you notice we have changed our packets from pink to red. Now, the difference between the pink was the STP, right? So these packets right here are the dynamic trunk protocol, which is part of Cisco switches, right? So it's sending this out to try to determine if those ports should be configured as trunk ports, right? So we'll get through this part. And now we are back to our pink, right? So STP again. So the STP process sends out a configuration BDPU, the topology flag, change flag is set, and then it encapsulates that PDU into the Ethernet frame, right? So the BDPU are the actual packets from spanning tree protocol, okay? And you'll notice whenever we go to the next layer, see how this is 1, 2, 3, 4, 5. You'll notice that it actually has 4 different connections, right? So it's only sending out 5 of those, 5 of those STP messages because it's only connected 5 devices to this one, right? So if it had 10, it'd be sending out 10 of those STP. But you notice now that I'm not sure when it happened. I think after we went through the DTP, right? Once it was calculated which one was going to be trunked, the protocol, then it was powered on, right? So we'll just go through some more of that, let that continue. All right, so notice right here, the first thing it's going to do is it's sending out an ARP request, right? Why is it sending out an ARP request? Because it doesn't know the route to the server yet. So it's going to create the DNS, right? Our layer 2 is missing here. So the device encapsulates the PDU into a UDP segment. Remember, DNS is a UDP protocol, operates out of port 53, right? So we know our local IP address. So this 10.1.1.103 is the IP address for here, right? And we know our destination IP address, but the default gateway is not set, right? So what does it do? The next top IP address is unicast. The ARP process looks it up in the ARP table, right? So it's not in the ARP table. So whenever that happens, it then creates this ARP request, right? Creates this ARP request that requests the target IP address. So that the next layer, right? So once it encapsulates it, it works its way down, right? So now we go to there's a couple of things that happens. Number one, because this is a newer network, right? So the MAC address was not on this switch, right? So it didn't know the MAC address for this switch yet. So now that it has received a frame, an ARP request from this device, it now has the MAC address for this. So it goes ahead and creates the table here. Right, so the frame destination MAC address is the broadcast. The multi-layer switch processes the frame. It matches the receiving port's MAC address, the broadcast address, or a multi. So this then encapsulates the PDU from the Ethernet frame. It knows that it's an ARP, and the active VLAN interface is not up, right? So it ignores it and then sends out the frame, right? It's still trying to locate where it is. So it sends that ARP request to everybody here as well to find out, hey, are you at this location? Right? Yeah. See, target IP address does not match the receiving port IP addresses. So it drops the frame, okay? Now this guy, so the ARP request target IP address matches the receiving port IP address, right? So it found our gateway, right? So the ARP process replies to the request with the receiving port's MAC address. So now it's going to go back and tell this guy. So the ARP process updates the ARP table with the received information, right? Takes it out and sends buffer packets waiting for this ARP reply. Right? Process takes out the packet from the buffer and resends it. Now I'm going to send it out. So now the ARP process requests for the target IP address. Sends it out again. What happens, right? So it sends out multiple ARP requests again to all of its connections. They say, no, that's not me. No, that's not me. No, that's not me. Here, Quad 8 finally receives that request and says, yes, that is me, right? Spanning tree protocol again, still working in the background. All right, so now that our PC knows the address for the DNS server, right? So it's going to send the query directly to the DNS server, okay? Okay. So this is the incoming, this is going to be the outgoing, okay? So the server receives the communication on layer 1. It's now matching the MAC address, which is layer 2. So the IP address is matching as well. So the device de-encapsulates the packet, keeps moving it up. UDP source port, right? So we know that the UDP is, in this instance, is going to be for DNS. So the port matches. And application wise, so the DNS server receives a DNS query, and then it has that information there, so it doesn't have to go to a root server, right? It has the information cached on it, so it's going to send the information back to the one requesting it. So what does that do? It creates that data packet at layer 7, and then it sends back a response. How does it do it? It starts to encapsulate that data packet and move it down that OSI model, right? Jumps from layer 7 to layer 4. It chooses the UDP. It's going to send it back as a DNS request. And where is it going? It's coming from, this is the source IP, coming from here, destination, right? 888.100, which I believe is right here to the router, right? And when it gets to the router, we'll talk about what ends up happening next, okay? All right, so we got to our router. So this packet, now that we're at layer 3, right? So it's the router. So the packet is coming from an outside network. The device looks up its NAT table, right? Network address translation. If you remember, NAT, what it does is it changes private IP addresses into public IP addresses and does the reverse as well, right? So the device looks up its NAT table for necessary translation. It has a matched dynamic entry for source and destination global addresses, right? So what that means is the destination global address is here, right? So this is the destination global address here. Eventually, it's going to be, this is the destination private address, not global, right? And this is the source global address. So the device translates the packet from global to local addresses with the matched entry. And then a device looks up a destination IP address in the routing table. So now it's just going to send it on over. All right. So received the information from the DNS. We now have a resolved IP address for the queried domain. So what will end up happening next is we have got a HTTP client, right? So it's starting here. Basically, the browser is going to try to make a connection to our server over here now that it knows its IP address. So what does it do? It's going to create a connection request. How's it going to do it? It's going to do it through TCP, destination port 80. If you remember, destination port 80 is HTTP, which is the unsecure web browser, right? It just so happens that this particular setup here is for HTTP, not for HTTPS. So the device sets the connection state to send. And remember, whenever we're dealing with TCP, it's called the three-way handshake, right? It's going to be a SYN ACK, and then an ACK, right? So it's going to send a synchronization request. This is going to send an acknowledgement of this synchronization, and then this is going to then acknowledge that back with the final synchronization. And then in the time being, it's going to, right, see, setting the sequence number for the communication, it's setting the ACK number for the communication, and the data length. All right, so it goes ahead and sends that packet over. We're going to go over. sends it out multiple, right? And the reason why it's doing that is because it's still trying to find out, like, are this switch hasn't determined if this IP address is if this isn't the IP address, right? This is still an ARP because it may have the address, but it hasn't identified which port coming out of here is for the correct address. Because this guy just happened to say, it just so happens that the IP address for Facebook is 888.10, right? So that's all this switch knows, is that that's the address it's looking for. So it sends out another ARP request to find out who is there. All right. So this is the one that responds, tells the switch that it's there. So this gets sent back. Now that this knows, it goes ahead and finalizes that TCP connection. All right. It's now reached there. Okay. Destination port 80, source port 80. Okay. Here's our source IP address, destination IP address. So this is as it's sending it back. Okay. Oh, let me back it up. Okay, so remember, this was coming in as a send, right? So the device sets the connection state to send received. And then now we're going to switch over to a send ACK, right? So this device, right, our server is now going to send the send ACK back across, right? And sets the sequence number 0. The acknowledgement is 1. Whenever you are connecting via TCP, the requests are numbered sequentially, right? So they will go up. So the one back is most likely going to be 2, right? It increments. So we'll see that. So send it back. All right, and this is now receiving it. Receives the frame. Next layer, next layer. Okay, so now it sets it, so it receives the send ACK, and now it is going to send back an ACK, right? And set the connection to established. See, the ACK number is 1, the data length is 20. Sequence number 1, right? Okay, so we've received it here. TCP ACK. This now sets it to established. So now it has gone through that 3-way handshake and it's established a communication with one another. Let me get through all this. Okay, now that we know more or less what's going on in the background, let's start this process over. And watch the packets. Let me press play here, and I have sped this up. Going to get the DNS server, the address. All right, so it connected to the send, ACK, and now it's receiving HTTP communication. Okay. And see, here comes a bigger packet. You notice how that was split up into four? That right there lets you know that the communication that it was sending at that point was larger than the MTU, so it had to split it up. If we were to click on those packets, we would see that this would be they would be numbered, right? Packet number 1, packet number 2, packet number 3, packet number 4. Now, if I'm not mistaken, this actually will give us the Facebook logo at the end of this. I'm just waiting for that moment. There we go. I got tired of waiting, so I went ahead and switched it over to real time down here. You can't see it because my head's in the way, but there's real time down here. Ended up switching it to real time.